Hello viewers, in today's lecture we are going to solve some problems based on shortest distance between two lines, right? So let us take this problem. Here we have to find the shortest distance between the lines whose vector equations are given as uh, equation 1, this is equation 1 and this is equation 2. Now uh, we know that the shortest distance between two lines is given by the formula uh, that is a2 minus vector a1 dot b1 cross b2 divided by magnitude of b1 cross b2, right? So this is the formula for finding out the shortest distance between two lines. Now here the first line is vector r. Here we have vector a1 plus lambda times vector b1, and the second equation or the line is vector a2 plus mu times vector b2. So the first line passes through the point vector a1, and the second line passes through the point a2, vector a2, that is 1, 2, 3, right? And the second line passes through the point 4, 5, 6, and the first line passes through the point 1, 2, 3. The first line is parallel to the vector b1 and the second line is parallel to the vector b2, and here this is vector a1, this is vector b1, this is vector a2, and this is vector b2, right? So our aim is to find out the value of vector a2 minus vector a1. So a2 minus a1 is 4I cap plus 5j cap plus 6k cap minus I cap plus 2j cap plus 3k cap, and this is equal to 3I cap plus this is 5 minus 2 is again 3j cap, and we have plus 3k cap, right? Now b1 cross b2 is given by the determinant I cap, j cap, and k cap, and here we have the second row is occupied by the components 1. Here we have 1, 1 minus 3 and 2, and the third row is occupied by the numbers 2, 3 and 1. 2, 3 and 1. Now if we expand this determinant, we get minus 3, minus 6 here, then we have minus j cap, we have 1 minus 4, then we have k cap, and here we have 3 plus 6, right? So this is minus 9I cap, this is plus 3j cap, and then we have 9k cap, right? Now let us find the dot product of these two vectors. So we have a2 vector minus a1 dot b1 cross b2 is equal to a2 minus a1 is 3I cap plus 3j cap plus 3k cap, and here we have dot, then we have minus 9I cap plus 3j cap plus 9k cap. So the dot product is 3 times minus 9 plus 3 times 3 here, and then we have 3 times 9. So this is minus 27 plus 9 plus 27, and these two get cancelled and we are left with 9, right? Now we have here b1 cross b2, so the magnitude of this vector b1 cross b2 is square root of minus 9 square plus 3 square plus 9 square, and if we solve this, we'll get here 81 plus 9 plus 81, right? And this is equal to square root of 171. And now if we substitute the value of this expression and the magnitude of the vector b1 cross b2 in this formula, we get the value of shortest distance as 9 divided by square root of 171, right? And this can be written as 9 over square root of 171 units. Now let us take this problem. Here we have to find the shortest between these two lines, and here the equations of the lines are given in Cartesian form. So let us first convert these two equations in vector form. So the vector form of the first line L1 is vector r, and this line passes through the point minus I cap minus j cap and minus k cap. Here we have the point minus 1 and minus 1. So we have the vector minus I cap minus j cap and minus k cap plus lambda times the vector. This line is parallel to the vector 7 I cap minus 6 j cap plus k cap, right? And the vector equation of this line is vector r, and this line passes through the point 3, 5, 7. So here we have 3 I cap plus 5 j cap plus 7 k cap, and here we have mu times this line is parallel to the vector I cap minus 2 j cap plus k cap, right? Now viewers, here we have converted these two Cartesian equations into vector form. So this is now vector a1, this is vector b1, and this is vector a2, and this is vector b2. And we know that the formula for finding out the shortest distance between two lines is a2 minus a1 dot, here we have b1 cross b2, and then we have divided by the magnitude of b1 cross b2. Now let us first find a2 minus a1. So vector a2 minus vector a1 is 3 I cap plus 5 j cap plus 7 k cap minus, here we have minus I cap minus j cap minus k cap, and this is equal to 4 I cap plus 6 j cap plus 7 it is 8 k cap, right? And the vector b1 cross b2 is given by this determinant, and the second row is occupied by the numbers 7 minus 6, and here we have 1, and the third row is occupied by the numbers 1 minus 2, and here we have 1, so here we have 1. Now if we expand this determinant, we get minus 6 plus 2, and then we have j cap, and we have 7 minus 1, then we have k cap, then we have minus 14 plus 6, and we have minus 4i cap, and then we have 6j cap, and then minus 8k cap, right? Okay, now after finding out these two vectors, now we have to find the dot product of these two vectors. So a2 vector minus a1 dot b1 cross b2 is given by, here we have 4, here we have minus 4, so it is 4 times minus 4, plus here we have 6, here we have minus 6, so we have 6 times minus 6, here we have 8, and here we have minus 8, so we have minus 16, this is minus 36, minus 64, and this is equal to minus 116, right? Okay, and the magnitude of b1 cross b2 is given by square root of minus 4 square plus minus 6 square plus minus 8 square, right? And the mod or the magnitude of b1 cross b2 is given by, this is 16 plus 36 plus 64, and this is equal to square root of 116, right? Now we have obtained the values of these expressions here, so let us substitute here. So the shortest distance is given by, here we have the dot product of these two vectors is minus 116, and the magnitude of this vector is square root of 116. So this is 116 divided by square root of 116, and if we rationalize it, we get square root of 116, right? And this square root of 116 can also be written as, here we can write 2 root 29, right? So the shortest distance between these two lines is 2 times square root of 29 units.